If you open your windows, you will see a bright spot in the sky. You'll think that at last the star went supernova and it is giving you this spectacular view. But that will not happen tomorrow, not next year, not in the next 50 years, and probably not even in our entire lifetime. Yes, I know many of you have seen my videos when I talked about the possibility of a star going supernova soon, but I'm getting a little negative on this matter. For most of human history, the night sky has looked calm and unchanging. But occasionally something extraordinary happens. A star dies in a violent explosion called a supernova, becoming brighter than billions of suns combined. Ancient civilizations recorded them glowing in the sky even in daylight. And today, you and I would love to witness one up close. Well, not too close. But here's the twist. We'll probably not see a major supernova in our lifetime, and the reasons are surprisingly scientific, not just unlucky. First, supernovae are incredibly rare on our galaxy. On average, the Milky Way produces about 2 to 3 supernova per century. That's roughly one every 30 to 50 years. But most of them remain hidden behind the thick cloud of gas and dust in the galactic disk. So even if one happens, there's a good chance we simply won't see it with our eyes. But we recently saw 2 novae. More about them at the end of the video. Now, let's talk about the stars we are watching closely, because yes, there are a handful of giant stars in our cosmic neighborhood that are ticking time bombs. The first one is Eta Carinae, a truly monstrous star system about 7,500 light-years away. It's so unstable that it already partially exploded in the 1840s in an event called the Giant Eruption. That wasn't a supernova, just an outburst caused by its internal chaos. Today, Eta Carinae is still extremely unstable, shedding mass through powerful stellar winds. Could it explode tomorrow? Possibly. Could it explode a million years from now? Also possible. Our lifetime means nothing to the stars. They burn on cosmic schedules, not on human ones. Next, there is the celebrity star Betelgeuse, the bright red shoulder of Orion. In late 2019 and early 2020, Betelgeuse dimmed dramatically. The world got excited. Headlines said the star might be about to explode. But then Betelgeuse returned to normal brightness because the dimming was caused by dust that the star itself had thrown out. More recently, research suggests Betelgeuse is hundreds of thousands of years away from a supernova. A few studies allow the possibility of 10,000 years, but that's still an eternity for us. So no, Betelgeuse is not about to give us the cosmic light we had hoped for. Another massive red supergiant is Antares, the heart of the Scorpion constellation. Antares is also nearing the end of its life, but its timeline is similar, tens of thousands to hundreds of thousands of years. Again, beautiful to look at, but not ready to explode anytime soon. There's also VY Canis Majoris, one of the largest stars ever measured. It is shedding mass violently and may go supernova, or even collapse directly into a black hole without a bright explosion. If that happens, we might not see anything at all except a sudden disappearance. So why do stars take so long to explode if they're already dying? Because dying is a slow process for massive stars. You can think it like this. You, me, your weird uncle, everyone is dying. Not today, not tomorrow, but maybe in 50 to 60 years or so. Similarly, stars, after they run out of hydrogen fuel, they fuse heavier and heavier elements one layer at a time. Each step takes less time, but some still last thousands of years. The only phase that goes extremely fast is the final one, fusing iron, which lasts only seconds. But we don't get to see that countdown. And this is the real reason we likely won't witness a major supernova. We live on human timescales, while stars live on cosmic timescales. To us, a few thousand years is unimaginable. To a star, it's just a breath. But there's something important to remember. Just because we probably won't see a massive star explode with our eyes doesn't mean the universe is quiet. In fact, we have recently witnessed 2 novae. V462 Lupi and V572 Velorum. Just a couple of months ago, a nova is different from a supernova. It happens in a binary star system where a white dwarf pulls material off a neighboring star and ignites a surface explosion. Novae don't destroy the star. They're more like cosmic flare-ups, but they are spectacular events, and the fact that we are witnessing this not just in telescopes but in real-time observation is amazing, and that's exactly what we saw recently. Astronomy today is not just about waiting for something brighter to appear in the sky. We now have neutrino detectors, gravitational wave observatories, and space telescopes like JWST that can sense the death of a star even if we don't see it directly. If a supernova happens anywhere in our galaxy, even hidden behind dust, neutrinos will reach Earth almost instantly, and scientists will know before a single visible photon arrives. No, I'm not saying neutrinos are faster than light. Light gets delayed, neutrinos don't. When a massive star collapses, the core implodes and forms either a neutron star or a black hole. That collapse releases a huge burst of neutrinos. They fly out of the star almost immediately. But the light from the explosion has a problem. It has to fight its way through the star's outer layers, dense plasma, gas, and dust, before escaping into space. This can take minutes to hours. Neutrinos, on the other hand, interact extremely weakly with matter. They just ghost right through the star like it's barely there. So neutrinos leave the star within milliseconds. Light gets trapped and delayed inside the star's body before escaping. So neutrinos aren't faster, they simply start racing earlier. We haven't received any significant neutrino stream from any of the stars, but you can bet that we'll see more novae like V462 Lupi pretty often, and we might have to be happy with that. Have you watched V462 Lupi yet? If not, then click on this video.